Everybody, my name is Mariano Rico. I come from Universidad Autónoma de Madrid, and the paper I will present is entitled, with a very long title, Automatic Guidance Tools for Enhancing the Educative Experience in Non-Immersive Virtual Worlds. And this is preliminary results from projects, believe, from our institution. This project has been funded by the Spanish Ministry of Science and Innovation under the program Explora. The project coordinator is Estrella Pulido, and researchers are David Camacho, Javier Alamán, and Gonzalo Martinez. We have a set of people that work for us, and they have developed all the details of the infrastructure. And in this site, you can see all the information about the project and the code or many manuals for using the system. Our objective was the Spanish high school students, and we have agreement with 4 Spanish high schools in Madrid. 3 of them are in Madrid, and the other one is in Catalonia. And we have made some experiments with real users. And here I will show you the result of those experiments. And basically we had some questionnaires for students and teachers, and the results of analyzing those questionnaires was a new set of identified tools useful for students and teachers. So our target was to enhance the students' programming experience, not the expertisement of the students, but the perception of technical subjects learning. Most high school students remark that technical studies are boring for them, or are not so interested as they expected. And another objective, another target for us was to simplify the work for teachers. They are very interested in these new technologies, but the effort required to develop new tools or to fill up questionnaires or this kind of things must be simplified, must be reduced in order to simplify life for teachers if they want to use this system. So the idea was that they can contribute with new tools, or they can extend or enhance our existing tools. So we think that the key of these 3D environments is to exploit the fact that these environments can be better than reality. So these virtual worlds can enhance the technical teaching and learning, and we focused in previous studies in different environments. Virtual reality, it's a matter of study for many years, and many good studies have been developed. So we learn from those works that immersive, the virtual reality traditional, and we move from immersive environments to non-immersive environments. Our environment, it's very similar to a 3D game, very popular for students, We follow the studies from Bailenson, and he work with virtual reality environments, immersive. So they make experiments using Hamlets, the head-mounted devices, and they studied the teachers' eye gaze, and they discovered that the more the teachers look at the students pay more attention, and they realize that the student's location is important, and essentially that the closer the student is to the teacher in a virtual environment, the better are the results. They pay more attention, and the angle between the view of the teacher and the position of the student, it's critical too. So the students' interaction, it's important too, and in these studies from Bailenson, they realized that they had a software capable of making a fade out of the students that were distracting to others, and this behavior improved the results of the group. So these kind of things were made in heavy immersive environment, but it was a key for us to realize that the eye gaze of students and teachers were a key for our studies. And another study closer, not so immersive, was the one from Stipto, and they used communities of caves that were interacting, and they provide a feeling of interaction between users. Each one of them was in a different cave, and they realized as well that eye gaze is very important. So finally, the studies from Harris, they used a real environment like the one we use. It's Second Life. They realized that the behavior of the people in virtual environments mimics the behavior in real world. So our tools provide these benefits, are cheaper than real hardware, and are easy to create. We have used OpenSim. It's a platform with open source, and it has a programming language in the environment. It's the Linden scripted language, LSL, and it's quite simple, and it's reasonable for providing behavior to objects in OpenSim words. And we have developed some tools, and we have making more tools or improvements, and the project will finish at the end of this year. So we have a few months to make more tools or improve the ones we have. And in this talk, I'm going to talk about the Students Monitor and the recommender system for students. The results are quite optimistic. We can be very well. Students are enthusiastic with these tools, and teachers are are enthusiastic too, and they want to make more software. They appreciate the manuals we gave them. Those manuals can provide them information for making new objects or making new tools. The architecture of belief is this one. We have teachers and the students, and they can use the browser for accessing the web page, the web site, and they can, for example, teachers can make groups of students in a very simple web application. And those groups are translated to the virtual world, and both teachers and students can access the virtual world through the Second Life client or any other Second Life compatible client like Hypo or anyone. And they can access the virtual world and can access the web pages through the web pages, and we store in our databases documents or information about groups or logs with information about the behavior of the students and teacher in Belief World. And here we have the scientists, which can use any software, for example, data mining software or any statistical software, to analyze the data provided by the environment. The Belief monitoring system is based, well, this is you can see here a schema of how it works. So when you access the virtual world through the viewer, you access to Open Simulator through the internet, and the monitor system get information from two sources. The first one is the one based in the LSL language, and it's provided by scripts in the tools. And the second one is the one we provide hacking the system. So we have modified the original OpenSim software, and we get logs about positions or chat or any information interesting for us, and the students don't realize they are being monitored. And the recommender system analyze the logs and provide feedback in the virtual world. So we have 3 tools: an interactive blackboard that teachers can configure, and it's based on the recommendation of the real teachers. So I think it's quite useful, and of course this blackboard logs information about movement of the teacher and the time, the delay that students require to get some information, and many information can be analyzed. And we have the students monitor. It's a tool for teachers. It's an object in here. Well, it doesn't matter. So, well, you can see there the aspect of the student monitor. You can see which students are attending or which ones are talking in between them or are distracted. So the students must wear a bracelet, and the other tool is the system for recommendations. And this is an example of the recommendation. So this is the view of the teacher, and the system recommends the teacher to pay attention or repeat the last 10 minutes of the lecture because the students are not attending. And our future works is to test tools again with real users and improve the interaction between the monitoring system and the users. And we encourage you to participate. And that's all. Thank you for your attention.